Hello there, I'm Thomas Hatsios, German American pilot flying the Boeing 787-900 to 95. We're going to be overflying Zurich, Switzerland, Germany. Then we're coming back to the Zurich International Airport, runway 14 for an ILS localized and landing. So right now I'm in the cockpit for the pre-takeoff preparation of the quality wings, Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing the cockpit instruments and displays of the functions of the Boeing 787-900 jet aircraft. I'm gonna start with the primary flight display that displays the airspeed indicator, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, barometric altitude above the sea level, the target altitude selected from the autopilot flight director system panel, the barometric pressure of the outside atmosphere and the vertical rate of climb descent of the aircraft in 10 hundredths depending on the steepness of the trigonometric angles. It decrease, you can climb descent. We have also the ILS localizer, the altitude indicator with the ILS localizer with the pitch slider in decrease and the bank angle in decrease. The artificial horizon. Also, we have the ILS localizer, the instrument landing system that receives the radio frequency transmitted from the threshold runways antennas of the runways we're gonna use for takeoff and for landing. So we have the threshold antennas of the instrument landing system, the ILS localizer. They transmit a radio frequency that is unique for each antenna and runway, and also for its magnetic north pole heading. So we'll be aligned with a magnetic north pole heading of 136 degrees for the runway 14 in Zurich International Airport, Lszh in Switzerland. So you'll see how we're gonna do that. So the ILS localizer will be aligned with that. For the horizontal localizer and the vertical angle of approach, the glide slope. So we're gonna be having also the ILS localizer crossbars. We're gonna tune the ILS localizer using the flight management computer or manually using the radio management panel. We have also the flight director crossbars for manual guidance of the aircraft and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies and the flight mode annunciator with the autopilot and the auto throttle later on vertical navigation mode. We have also the HSI, which is the horizontal situation indicator that also displays the magnetic heading and track and the integrated display of the flight plan we're gonna be creating later. So we have also the navigation display. The navigation display that displays the horizontal and vertical profile of the aircraft as it flies. You can see the terrain and weather reflections from the weather radar. You can see the red, green, and amber or yellow indication of the terrain around you and also below the aircraft as we fly. We can see also the magnetic north pole and the geographic north pole, the magnetic variation depending on where we are in the world. We have also the GPS position of the aircraft, and also we can see in the terrain map, you can see in the horizontal profile the airports around you, where they are located, the distance from our aircraft. Also around airport we have the display of the runways and the taxiways, the runway length, the runway heading. Also we have the name of each airport with a 4-letter account name. So we have the Lszh in Switzerland displayed in the navigation display. Also you can see the 4 stations, ADS and DBs, which are navigation aids, the nav aids. Also you can see the waypoints which are horizontal and vertical navigation fixes. We're gonna have to select some waypoints from the flight management computer. Later in a few minutes I'm gonna show you how to use the flight management computer to create a flight plan or a flight path route. So we will select a route from a departing airport and destination, arrival, airport and runway. So we're gonna be having departure and arrivals and seats, instrument departure, waypoints and fixes, stars, and arrival, waypoints and fixes. And we're gonna be having the intermediate waypoints we have to fly through. You will see the purple magenta line of the flight plan we're gonna create later. So we have also in the navigation display we can see the display of other aircraft that fly around our own aircraft using the transponder. The ADC transmits or receives the transmits our frequency to other aircraft and the air traffic control and receives from the other aircraft. And you can display, you can make calculations using its computer about the other aircraft position, the distance from our aircraft and bearing, also the altitude difference from our aircraft, how many hundreds or thousands of feet are above or below our aircraft. Also, you can calculate whether they climb or descend with respect to our aircraft. Also, you can calculate the velocity closing in between our aircraft and the other aircraft. It will give us a warning from the TCAS system, the Traffic Collision Advisory System. If we have an incoming collision in the air, we will make an avoidance maneuver. Also, you can see the taxiways and the runways. Also, we have other aircraft. We're gonna see also the flight controls over here. I'm gonna show you the flight controls of the aircraft. I use the side stick that I have, which is identical to the Airbus aircraft side stick. I can use to control the yoke of the Boeing 787 or other Boeing aircraft. The yoke, the control wheel. So we have the yoke for controlling the horizontal stabilizer elevator movement up and down to climb and descend the aircraft. Also we have the ailerons and the spoilers in the control wheel to make left and right turns, and also the rudder pedals for the vertical tail rudder, the vertical stabilizer rudder, and also for the nose wheel steering. Also we have the tiller. So you can see here we have the side stick, the Lszh stream 3D. I can make climbs and descents of the aircraft as we fly, make turns to the right, make turns to the left like this. You can see it's identical to the Airbus. So you can see also the outside view. You will see the movement of flight controls like climb, descent, rudder, make right and left turns, ailerons, spoilers in the side stick left and right. So we have I'm gonna show you also the thrust levers here. I have this thrust control over here, so I can move the thrust levers forward and up. As you can see, I have the horizontal also trim stabilizer, this switch to control the horizontal trim of the aircraft. So you move the slider back and forth. We have also the autopilot disengage switch for the Airbus, and the side stick priority here, and the push to talk like in the Airbus aircraft. As you see, is identical, pretty similar. So we have over here, you can see the engines as we move forward and aft. I can set the thrust levers to like 50, 60, 100%, like in takeoff. You can see we're having some red warnings here that we're not configured to take off yet. You're gonna see one by one all the displays of the aircraft, the flight management computers here, the mouse pad. You will see the horizontal trim stabilizer, the thrust reverse for the engines, the auto throttle disengage switch, this switch, and the takeoff ground, thrust reverse, the flaps position over here. You see the flaps movement up and down. So we have the flaps position, stabilizer trim, rudder trim, the engines, the left and the right engines over here. So we'll start showing you the controls of the aircraft. So you can see we have the horizontal trim stabilizer here to trim the aircraft up and down. You can see elevator trim, right click, left click down, right click up. So moving this way you pitch the aircraft nose up as you fly, and moving this way you pitch the nose of the aircraft down as you fly, because you trim the elevator, the tail of the aircraft elevator up, and you trim the elevator down, so you have the aerodynamic effect. In flight to balance the aircraft, this helps the pilot relieve the air pressure, as you can see from the elevator, from the tail of the aircraft. Left click down, elevator trim, left click down, right click up over here. So we trim the elevator up and down. We have also the autopilot disengage over here, autopilot disengage switch, and the head up declutter over here. Also the flaps speeds here, limits, some engine display. So we have over here, you can see the position of the horizontal trim stabilizer, because when you trim you move the elevator up or down like this. You trim it, you trim a position of the elevator So you can see the movement, elevator descent or elevator climb the aircraft as you fly. So you have the aerodynamic effects. You can also move the yoke instead of trimming the aircraft. So you can move up and down the thigh stick in the Airbus or the control the yoke of the Boeing 787, which is having the same function with the Airbus side stick. There is no difference. You just move up and down, climb and descend, make left and right turns like this. Instead of having the side stick, you have the control wheel for the ailerons and the spoilers. So I'm gonna show you also the outside view of the flight controls. I will talk to you about the Newton's physics, aeronautical and aerospace engineering. There are some principles we need to know for flying the aircraft, the Boeing 787-900 or any aircraft. We need for the air transport pilot license and commercial pilot license, aerodynamics, aeronautical, aerospace engineering, and the Newton's physics and the new theory of fluids. So you're gonna see now. I'm gonna show you the outside view over here. So going the outside view, you can see here we have the aircraft. You can see the forward wings of the aircraft over here. Hold the weight of the aircraft as it flies is divided over the surface area of the forward wings that produce the lift force from the aerodynamic from the airflow of the air. So we have higher pressure below the wings, lower pressure above. So we have over here, you can see the thrust from the engines, the vectors that move the aircraft forward to accelerate and provide the aerodynamic force from the wings. So we have the jet plus these vectors from the engines. You can see the exhaust over here of the high pressure compressor and turbine over here, and also we have the front fan and the low pressure compressor and turbine, the combustion chamber, and also the exhaust gas nozzles over here at the cone, and also the bypasser, this round over here, which has bypasser from the front fan, which is not burned inside the engine. So we have also, you can see, so we have also here both left and right engines, turbofan engines. We have the mean aerodynamic chord position here, the Mach, which is 23% of the mean aerodynamic chord, where the maximum aerodynamic lift occurs in the forward wings. It's also the position where the stall will begin. As we fly, the airflow becomes detached and the aircraft might gonna fall if we fly, so we need to monitor here in the primary flight display all the time. You're gonna see if the airspeed is gonna decrease, and we have an angle of attack that is gonna make us stall. So you monitor the airspeed will give you also the angle of stall. So you'll see with an amber or yellow and red indication here the warning for the stall. So we increase, this is the airspeed tape, so we need to accelerate the aircraft, move the thrust levers forward and push the yoke or the side stick down until we have exit stall condition. So the airflow becomes detached when installed for a given angle of attack and airspeed. Also here you can see we have the fuel flow to the engines. We have the left and right wing fuel tank over here in the center tank. We have 30% right now in the left and the right wing and 10% in the center. Also where the mean aerodynamic chord is in the forward wings is the center of gravity over here of the aircraft. So we control the yawing axis from the center of gravity, the rudder. So we can make with the rudder left and right turns like this, the rudder control from the rudder pedals over here. So when you move the rudder pedals like this, you move the rudder axially. I have the side stick for doing that also. So this makes the rudder control. So we have also we have the nozzle steering over here. You can see we have the rudder also for the nozzle steering, left and right nozzle steering, and we have the control wheel also interconnected both sides. So we have all flight controls. We have the nose wheel is deflected from 0 knots up to 45 knots to like 76 degrees, either left and right turns alongside with the rudder with the rudder pedals. So you yaw the aircraft. This is the yawing axis using the rudder and the nose wheel, forward nose wheel. Deflect 76 degrees up to 45 knots. Then at 45 knots we have the rudder becomes aerodynamically effective above 45 knots, or like 70 kilometers an hour in takeoff. So we have the rudder aerodynamic effective at 45 knots, 70 kilometers an hour, and we have the deflection of the nose wheel is decreasing from 76 degrees to like 7.6 degrees, then at 80 nautical miles per hour, 80 knots, or 144 kilometers an hour. We have only the rudder aerodynamically effective, also vice versa as we land. So the nose wheel is deactivated, it deflects to 0 position. It's locked to 0 position automatically from the computers. So we have only the rudder for steering the aircraft in the runway for takeoff above 144 kilometers an hour or 80 nautical miles per hour. So we have the rudder pedals again for that. You can see also the rudder pedals have the toe brakes over here you can press, and also we have the nose wheel steering the tiller for slow speed nose wheel steering over here. So we have also you can see the axis. We have the wingtip axis from one wingtip to the other. It's the pitch axis of the aircraft. You control the pitch of the aircraft in the Airbus aircraft. You move the side stick up and down like this. So you climb and you descend. So side stick up, back, or up, you move the elevator up. Side stick down, you move the elevator down. So this is the pitch axis from one wingtip of the aircraft to the other to control through the axis again from. So you can see the control column over here in the Boeing. You climb and descend, moving the side stick in the Airbus back and forth. The Boeing is the control column of the yoke, like this, very easy. Both sides again are interconnected. The captain and the first officer always move together in the Boeing aircraft. In the Airbus you have the side stick priority button. You take either side control or dual input. So we have the elevator climb descent. Also we have one more axis here from the nose to the tail of the aircraft, like this. Transverses all other axes is the rolling axis in the Airbus. You make left and right side stick like this. Side stick left and right. You got the ailerons and the spoilers in the Airbus, left and right. In the Boeing you have also the spoilers, the ailerons and the flaperons. One extra thing, the flaperons movements. So you make left and right turns. Again, as you can see, side stick in the Airbus, left and right, either side. So also in the Boeing is the control wheel, as you can see. Left and right is the rolling axis, the longitudinal axis of the Airbus. Left and right turns is left and right turns again, but with the control wheel instead. So it's very easy. You can see again all flight controls interconnected. Side stick deflection is proportional to the yoke deflection. All flight controls so that they move together to have coordinated flight, like the rudder, aileron, spoilers and elevator. So again you see all flight controls together over here. And we have one more, we have the bottom surface of the wings. You can see using the burning ethereal fluids we have the flaps extended, and also as we accelerate for takeoff the airflow is moving slower below the wings. have higher air pressure, which pressurizes using Bernoulli fluid, pressurizes the wings and the weight of the aircraft up into the air as we accelerate to like 250 kilometers an hour. Also, the airflow above the wings using the Bernoulli fluids, because it's more curved, is moving faster, so we have lower air pressure, which sucks the aircraft weight and wings up into the air. So this is the basic aerodynamics we need for the air transfer. Pilot license and the flight controls also effects, so you can see moving up and down, elevator. Also, I'm gonna show you one more view of the flight controls of the Boeing 787 over here. One more view, then I'm gonna show you the rest of the systems of the cockpit. So we're gonna make also the engine start demonstration, set up the flight management computer. We're gonna make a complete flight from takeoff, climb, cruise, descent, approach, and landing in the end part of the video. So stay with me until the end part of the video to see the complete flight of the Boeing 787. The complete flight with me, full manual flight. So stay with me until the end part. Now this view of the, you can see also having the setup here, the computer. You can see I'm using my side stick, my computer, the keyboards I have, and the mouse pad over here also to control everything inside the aircraft. So this is my machine right here. So we have this view of the aircraft flight controls again. I'm gonna show you right now. So you can see here. I'm gonna show you also the screen. So we climb and we descend like this. Climb, descend, make turns to the left, make turns to the right. So you can see over here I have the full flight controls of the aircraft using my side stick, the Lszh Extreme 3D, that is identical with the Airbus. We control flight controls of the Boeing, no problem with that. We can dual functions also, the horizontal elevator trim over here, and the thrust levers. So you can see one more view of the aircraft screen. Hope you like it also. Oh, here we have better view now. We have also over here the screen, so you can see better with the screen over here. So hope you have a better view now, because I'm trying to change the view from the screen. The side sticks, so we can climb, we can descend, we can make turns to the right, make turns to the left like this. Hope you like the deflection of the flight control. You can see how realistic it is. Also the thrust levers over here. We have the thrust control with the thrust levers back and forth like this, increase and decrease the engine's thrust over here. So we can use the flight controls climb the descent, make turns to the left, make turns to the left, and make turns to the right, like in the Airbus, also the Boeing. No problem with that. So you can climb, you can descend, make turns to the right, make turns to the left, ailerons and spoilers, like this. So hope you like it. We have also again the view from inside, and then we go for the rest of the systems. As you can see, so we can make turns like this, left and right, up and down, all flight controls over here. Nozzle steering, we have the rudder pedals again, and the vertical stabilizer, the rudder. So this is the full control of the Boeing 787, the flight controls. Over here using the side stick from the Airbus. So you climb, descend, make turns right and left over here. So we'll show you now the rest of the systems of the aircraft of the Boeing 787. So this is enough for the flight controls, as you can see. Functions, so we make turns left and right, ailerons, elevator, climb, descent. This is side stick deflection proportional to the yoke deflection. In the Boeing we need to override one side. They move together, they're interconnected flight controls. Both sides, the captain and the first officer. Now in the Airbus you have the side stick priority over here, so we go for the rest. Now I will show you the horizontal trim stabilizer system over here. Then we make the flight management computer. So you see a little bit the horizontal trim stabilizer. You can see again horizontal trim stabilizer, elevator up, elevator down. I forgot to mention one section, the alternate. So this is the manual flight control computers mode, the normal elevator trim, left click down, right click up. So we have the elevator trim over here, this trim switch. When I fly I can use instead of using this switch over there. So you can see the tail will move up and down as you fly the elevator. Also you can see the position here, how many degrees you have over here. Trim the elevator. So we have right now 4.75 degrees. Inside the green body it's for takeoff. Inside this green indication, the rudder trim, also the flaps, the flight control. So we'll talk to you about the engines also. So we have over here the flight control computers. This is a fly-by-wire aircraft, primary flight control computers in the normal, in the auto position. We have also the air data computers over here with the inertial reference, GPS receiver, pitot, airspeed, and also altitude barometric altitude. We have the flight control surface over here. So the air data computer is for this section. I'll talk to you now. So we have the alternate flight control mode over here, channel, flight control computers channel. Over here, nose up and nose down. Again, you trim the elevator up and you pitch the nose up, and you trim the elevator down, you pitch the nose down as you fly. We have also the parking brakes over here, as you can see. So we have also, this is the horizontal stabilizer cutoff switch. you open this guarded switch from normal to cutoff. You have a failure over here from the flight controls that is created from the hydraulic systems malfunction that affects the movement of the actuators of the horizontal stabilizer. It will give you a degradation from normal to alternate the director to mechanical backup the primary flight control computers like in the Airbus. But the Boeing has this feature. You will have malfunction of the autopilot flight director system panel, the auto trim function, because you have also automatic trim. So you have for the Boeing 737, Boeing 747, Boeing 757, Boeing 67, 767, Boeing 777, and Boeing 787 over here. You move from normal to cut off this red guarded switch stabilizer trim over here, and you have only the alternate pitch trim over here. You lose the automatic trim, you have the alternate, and you have also the manual all the time over here. So you have also the manual pitch trim elevator over here. You trim the elevator manually over here all the time. So we have also the fuel control, the fuel flow to the left and the right engine. The left and the right engine thrust levers, auto throttle disconnect, the speed brakes. Over here you move speed brakes, extend, retract, the flaps that I show you. Also we have a few more things to see here. We have the fire extinguishers over here. The left and the right engine pull out and switch the transporter of the aircraft to transmit its code and receive from other aircraft, calculate altitude. The radar trim over here, radio and communication panel over here. You tune navigation radios and also high frequency communication with the control tower. You tune the frequency of the control tower or the wireless localizer, satellite, ground proximity, weather, transporter over here. Also you have other features. We have also one aircraft is coming for landing right now, a Boeing 737, as you can see. It's coming into the runway for landing. It's landed. So we have other features over here for the aircraft systems we need to know. So we have the displays here very quickly. You can see we have the primary flight display, the displays from the air data computer. Over here we have the air data computer that controls the pitot static, pitot dynamic, GPS, also receivers, laser, gyroscope, precession, acceleration, also the longitude and the latitude of the aircraft, also the magnetic north pole and the geographic north pole, and the radio altitude, other features, the angle of attack, rate of climb, descent. So this control all features the air data primary flight display, navigation display from this air data computer. Also we can change the settings. You can see the primary flight display. You see the airspeed indicator, the airspeed selected from the autopilot flight director system panel. Right now the airspeed is 13 knots, but we're not moving. We have 1,430 feet above the sea level with this barometric pressure 29.92 inches of mercury. So you see 29.92 inches over here, 200 radio minimums. You can see we can climb and we can descend using this needle, the vertical speed indicator. So we can climb like 500, 1000, 1500, 2000, 3000, 6000 feet per minute. You see how fast the aircraft will climb or descend. Also the steepness of the angles inclines to descend is set from the autopilot flight director system panel. So this is the altitude, barometric altitude tape, and also the airspeed tape, the angle of attack, takeoff, go around the flight mode, annunciator, autopilot, auto throttle. So we have takeoff, go around, flight director, flight management computer. These speeds not displayed right now. Radio altitude 2 feet, -2 feet, so we can display like plus 2,500 feet. So we have the pitch lateral degrees. You can see 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20 degrees for pitch up and pitch down as we fly the aircraft. You will see also the stall speed displayed with the amber and red. Also the flap limit, the never exceed speed, maximum Mach operating. So we have also pitch ladder in degrees, like 20 degrees up and down. We have also the bank roll turns over here. We can turn like 5, 10, 20, 30, 45 degrees. How many degrees we turn the aircraft. You can see the wings moving left and right. The wings level right now. These two symbols. We have also other symbols to see and to know for the aircraft. You can see the barometric, very important, the barometric altitude. Over here 29.92 inches of mercury give us this barometric altitude, the landing altitude radio minimum. So we set the barometric pressure. You can see the FS panel over here. Very quickly we have the barometric setting, inches of mercury or hectopascals, 1013 hectopascals or 29.92 inches of mercury. We can increase or decrease the value. We have minimums, radio plan for the display of the map over here, and the range in nautical miles, the distance you can see far away over here. So right now it's 80 nautical miles over here, and the magnetic North Pole versus the geographic. So we have range plan, menu, map, also weather, radar, traffic. You can see other aircraft flying in the terrain displayed like in the radar. So you have accept, cancel, reject over here, the warnings. You can see also systems, CDU over here, info, checklist, communication, navigation display. Over here engine, ACAS, left and right multifunction display. You can change the screen's view or expand the view, like have an expanded map view, like over here you see all the airports further away, like Germany, France. You can see all the way to England or Netherlands. You can see the Switzerland down here that we are located. Also the other side view displays the same things. So you see the autopilot flight director system panel should display the same features like the displays here. You can see the terrain with amber, red, higher elevation, lower, and in green below the aircraft. You can see the terrain elevation 4,600 feet and 1,600. The airports right here, left has to be Lszh. Here is Germany, EDTL. I think it must be Düsseldorf. We have the Munich further away. So we have also the elevation of the aircraft as we're gonna be flying above the ground level. You can see also this purple and magenta lines. So we have the airspeed selected 200 knots, the altitude 10,000 feet, the magnetic heading 360 degrees, the elevation also 10,000 feet. So you see the autopilot now, flight director system panel. One more thing we need to know before some the aircraft for flying. So the autopilot engages. In case you have also the airspeed heading 360 degrees, airspeed in nautical miles 200 nautical miles right now, and the altitude, barometric altitude 10,000 feet. We can set also vertical speed. So we're gonna change these settings. The display the same things in both sides. The primary flight display, you see 200 and 10,000 over here. You see 200 airspeed 10,000 in the autopilot. So this sets the auto throttle for the airspeed, the automatic throttle. So we have 200 over here nautical miles per hour and 10,000 feet and 360 heading. We can change also here. We're gonna see the aircraft flying above the ground level. You will see how far above you're gonna be. You can see the triangle is the aircraft. We have set right now 10,000 feet over here. For climb, we're gonna set higher. So we have the autopilot over here. Engage, disengage switch over here. You can see the pilot disengage like this. The airspeed over here, you can set higher or lower airspeed like this. We have the L1 with the VNAV not yet activated. Auto throttle left and right over here. Climb continues, auto throttle, flight level change. Also we can press some switches to arm some modes. Bank roll over here and heading, magnetic North Pole heading. We're gonna use 136 degrees over here. So we go very quickly now. We have the hold, we have the vertical speed, we can descend the aircraft, you will see the minus, or we can climb, you will see the plus sign, like 3,500 feet or arm. We can also set the climb over here, altitude. We can set like 35,000, and the whole board localizer and approach for the autobahn. Also some other functions. We need to go very quickly. See a couple more things. The engines. So we have the engines here, left and right engine indication from the Farex, low airspeed, low speed starter, low press compressor and turbine of the turbofan to put the engine, the left and the right engine, 90.8% takeoff limit, 99.2, green, red, green, red never exceed limit, and green the active limit, exhaust gas temperature, and 2, which is the high speed starter, half high press compressor and turbine with turbofan to put the engine, left and right. Fuel flow per engine per hour, 1000 kilograms, 1000 pounds, oil pressure, oil temperature over here, oil quantity, vibration of the end two stages of the engine. So then one is the low speed starters have low press compressor turbofan to the engine, low speed starter and shaft or spool, and the high speed starter and shaft or spool, high press compressor turbine of the turbofan to the engine. We have also the landing gear extender retract over here, alternate gear auto brakes over here. Also the cabin pressurization, which supplies pressurizer from the N2 stage of the engine in most aircraft. You see the pressurizer supplies cabin pressurization. Outflow valves open and close, so we climb, we pressurize, we descend, we depressurize the cabin. We climb to like 43,000 feet, the cabin altitude should be 6, 7, 8,000 and the differential pressure 7.88 psi. You see outflow valves in the manual, in the auto we need nothing to do. Also from the engine we receive oxygen regulation over here in the flight, cabin pressurization. You see also the hydraulic fluid tanks pressurization. All these are controlled by the Farex. The Farex are the full authority. These electronic control computers. One installed per engine gearbox, wheels are redundancy. When it's unfazed, the other takes over, controls, monitors, and displays all the engine data. We see the engine's indication. Now we go for the flight management computer setup, the flight plan of the aircraft. So you see I'm gonna use this mousepad very quickly, set up the flight plan and some data we need for the aircraft for flying. So you see we have this mousepad touchscreen over here. We set the index, the molded identity, position, performance, takeoff, approach, annunciate, status. So we go back, the view and change over here for the other view, and we go very quickly right now. So we have the mousepad here, the thrust, flaps, position here. You can see on my computer and the autopilot. So we go back here. We have identity set very quickly, step Boeing 787, position Lszh, Zurich International Airport, Switzerland, the coordinates, inertial coordinates. Initially we use 0 fuel weight plus fuel on board gross weight for takeoff, so we have 322.7 thousand pounds plus 34,000, gross weight 357. So we set first the route, Lszh, Zurich International, origin, also destination over here. So we set one more time, clear the discontinuity, and we set up departures and arrivals very quickly. So we have active route, not yet activated, it's displayed with blue. So we say go in the departures over here. You see departures, we can select runway 10, 14, 16 over here on the right side. You see I'm moving the mouse. The purple shows, so I'll select runway 14 for departure, and Zurich Alpha is the C, the other instrument departure waypoints and fixes, and crew horizontal vertical indication fix, and altitude and concert. We're going to arrivals now. For the arrival of the aircraft, approaches, VOM 16, 2834, ILS 14, ILS 16 over here. We can select ILS 28, ILS 34, GLS 14 localizer, localizer 34. So we're going to the previous page. We select ILS 14, Trans-Amic key over here, transition, and the stars, the other terminal arrival weapons fixes, Negria 1 Alpha over here. So we have the legs, the route is not yet active, displayed with blue, first waypoint, after departure, second, the airspeed and the altitude, So go one by one. Zui 6 nautical miles, climb to the Nigria, then descend for approach and landing, trans through Zurich 701. So we need to activate that. We go initialize again, 0 fuel weight plus fuel on board, reserve fuel, and the cruising altitude 25,300 feet, cost index 100%, fuel freezing temperature -37, cruising center of gravity 28%. So we need to execute. You will see it will activate the route displays with white and purple over here. So we have the first waypoint after departure heading of the runway 136 degrees to nautical miles 250 knots 1900. We make left turn after 135 nautical miles, 6 nautical miles is Zui, 301 knots, 6000 alpha, heading 052, heading 071 is the Nigria, 26 nautical miles from Zui. Keep climbing to flight level 22,200 over here. With an airspeed 301 knots. Then Mativ, we make right turn 12 nautical miles, 320 knots, airspeed 11,000. We descend for approach and landing 11,800. And Namiki 6 nautical miles, heading 258, 276 heading 9 nautical miles is the Zui from Namiki. Zik 701 6 nautical miles for approach 180 knots, 6,000 alpha. Then TRA 10 nautical miles, C114 4,000 feet, Osnem. TRA 5,000 feet, Osnem 175 4,000 feet, 5 nautical miles. We make left turn for approach and landing, and the runway 14 136 heading 8 nautical miles from Osnem over here. So we set 15 degrees of flaps over here, center of gravity 23%, 4.35, and the takeoff speed we want to rotate for this gross weight and the runway. So we have also departure arrivals, alternate VNAV progress over here, FMC communication hold. We can hold over a waypoint and set a fix over here, and also the navigation radio tune Lszh or VOR. So we go back in the cockpit. We need to set up the APU to start the engines very quickly over here. Start the APU, the auxiliary power unit. Also the lighting, we're gonna set also a couple more things. You can see we have the left and the right IDG, the gray drive generator contactors, 100 to 200 volts for 100 Hz frequency, 120,000 kilovolts the battery, primary flight control computers in the auto, air data computers over here, flight control surfaces, the battery downwind power, FD door, passenger oxygen over here, window heat over here, the rammer turbine left and right engine driven, hydraulic pumps in the off position. You see what it displays. Then back to the auto very quickly. We set. Also we have the on or auto. We have the wing and edging, the eyes on or auto for this flight. Also we have the cabin pressurization system. You see the outflow valves in the auto or manual. We use the outflow valves to line the descent like this. So we set back in the manual. From the manual to the auto, we have air conditioning, ventilation, receives pressurizer, oxygen. Also we have over here we have the recorders, the cargo and APU fired. We have the electronic engine control for the left and the right engine that controls the fatigue, normal and alternate mode, and the auto start system, automatic or manual start. We have the nozzles. We can dump some fuel if we arm this switch and select the nozzles and how much to remain to make emergency landing. We have fuel booster pumps left and right wing. The crossfeed valve is off. If we turn it on, we can feed either engine with other pump or either tank. We can also balance the fuel between the left and right wing over here. So this is the fuel booster pumps. So this is all the overhead we need to know. We go one more thing over here. We're gonna start the engines. So we see the system display over here. You can see we have the hydraulics over here. Hydraulics, the APU is running, oxygen and liquid cooling, the electrics over here. You can see left and right IDC 120 to 100 volts for 100 frequency, 120,000 kilovolts. The APU also running. The APU load cell and main batteries, APU battery voltage, so you see 31 volts. So we have also the hydraulics over here. You can see left and right engine driving, primary demand, set-off valves, isolation for emergency, electric also, and the pressure 5100 psi system, or the quantity of hydraulic fluid, where the hydraulic system fluid goes, which system uses, like the flaps or the reversal fuel. On board the aircraft we have the left and the right wing fuel tank, center tank, 11,000, 11,000, 11,000, total 33,600. The long high pressure fuel valves left and right engine are open and feed both engines from the left and the right wing or center tank. This is the green line from center tank. The APU is fed from the left wing using the DC motor. We have also the circulation of fuel in flight, because the fuel will gonna freeze in flight. You see the minimum fuel temperature. We have the automatic recirculation. You see minimum fuel temperature minus 37 degrees, and the fuel temperature right now. So we recirculate automatically the fuel and the lubricant, the oil. Also the crossfeed valve is off, but we return it on. You can feed either engine without a pump or either tank and balance the fuel between left and right wing. The air pressurizer from the packs from the engines for oxygen. Other systems, doors are closed. Cabin can be pressurized. The gear, temperature of the brakes, pressure of the tires, flight controls over here. You see left and right flight controls, elevator, flying descent, rudder pedals also. FX display for maintenance. Over here, systems, circuit breakers over here. So we go back, hydraulics. We have one more thing to see the checklist very quickly. You see normal menu, what to do before start, after takeoff, descent, approach, landing. We have the communications also. So go back to navigation display over here very quickly. We turn off both engines over here. So you see both engines off position. Fuel control to the off. You'll see what it displays here. You'll see fuel starvation. So we have also the warnings. This is the hydraulics. Will be off in a couple of seconds. So we have the hydraulics, also the wings off. So we're going over here, restart very quickly, the auto start mode, as you can see, in the start in the automatic. So we see the configuration, other indications in the overhead panel. We're gonna see now we have pressurizer from the APU is increasing to 80%. We have only pressurizer, we have no fuel yet, so you see only pressurizer right now. Above 30% we can set the fuel control over here in the on position, fuel flow, fuel valves, both on. So we see the auto start kicking in. Now we have both pressurizer from the APU and fuel. So auto start over here, automatic start. $49, 50%, 51. So you see the messages. So we have 61. Both engines are running. We can go for takeoff. Flaps up over here, speed brakes up, advance the thrust levers also set up, or you can see the navigation display over here. You're gonna see the flight plan. So we advance the thrust levers and go. Parking brakes off. So we take the clearance from the air traffic control. The runway is open for us. We don't need to hold into the runway. We just taxi into position for takeoff. So we use the tiller here for alignment, as you can see. So we advance the thrust levers to take off ground, and also the flaps a bit higher. So you can see we can press the yoke down like 80 knots and align with the rudder pedals to the center line. So we have 100 nautical miles. Let the yoke off. 120 V1. We rotate, we pitch up slightly, like 9 degrees over here, as you can see. 9 degrees pitch up. And we take off. So we have the takeoff, positive rate of climb, loading gear up, retracted. So you can see right now we are like 1,400 feet above the ground level. You can see the airspeed is 178 knots. We have the stall speed amber, yellow and red. We are 2,000 feet above the ground. You can see the green line here is the ground below the aircraft as we climb. We are 2,400 above the ground, but 4,000 above the sea. So you can see here we are like 2,000 and a half, 3,000 feet above the ground level. You can see the ground, the terrain below you. How many thousands of feet right now? It's 2,000 and 3,000 right now above the ground. We keep climbing, as you can see. So you see also the airspeed 151 knots. You can see the terrain around you also, the flight plan. We're gonna follow as we fly. You can see also further away. We need to monitor more the airspeed right now all the time. So you can see green, yellow, amber, and green and red is the terrain around us as we climb. So we need to fly through the waypoints, the flight plan. As you can see, the vertical also flight plan. Gonna be flying through. You can see the runway position is extended here. So we make the turn in a couple of minutes here. So you can see we have the runway here. We leave behind the runway, and we have the legs here, and we start the turn like this small control, and we make the turn around. So we have 14 more minutes to fly the aircraft, the video to end. So make a more rapid turn over here. You can see we need to align with the flight plan here with this magenta purple line that we fly, also the airspeed. So we're gonna have both sides of the flight plan displayed over here, also the right side. So make a small turn over here. So we have beautiful view, the aircraft as we climb. A little bit more airspeed, maybe need so. I hope you like this crescent and the beautiful one more aircraft, the Galaxy. So this is a beautiful view over here from the aircraft from the Boeing 787 as we climb through Switzerland, the Swiss Alps. Also we have the lake over here, the France in this side. And now the Boeing 787, as you can see. Making a turn over here, aligned with the flight plan. And we have 11 more minutes to go back to the airport. So gonna keep climbing over here, flying a little bit 15,000 feet to climb a little bit higher rate. So you see also the view from the cockpit inside as we're flying after takeoff. You can see autopilot here, settings, autopilot, and also the engines control, the thrust levers, everything, flight management computer. Make a small turn over here towards the left, also the head-up display as we climb. And we have a few more minutes to go back to the airport. We need to align here with the this side, make a small turn, as you can see, align with the lines of the flight plan over here. As we keep climbing. So you can see we have the Negri is the next waypoint we have to fly through. We have the wind direction speed, the stall speed here, the airspeed. So we need to make turn in a couple of minutes. You can see we are flying here. The France, this side, this Germany, Bayern Munich, my homeland, Germany over here. The Swiss Alps and beautiful lakes. So we have the Swiss Alps here. So we're going back to the airport very fast, rapid turn over here. So we use a little bit right rudder if needed to make more rapid the turn, as you can see. So we are crossing 20,000 feet right now, 7,000 meters. And we are flying the Germany here, Bayern Munich, very beautiful. And the France behind us. So we have the Boeing 787, beautiful view. As we turn over Germany and the lakes also. We need to align now with the flight plan and go back to the airport for landing. We have a few more minutes, so make more rapid turn over here, many degrees faster. Use a bit right rudder, as you can see, and align again with the flight plan. So this is full manual flight. As you can see, maybe a few more flaps over here, have a little bit more airspeed increase. So we need to align again with the flight plan here. So we have here the chemtrails, the frozen vapors, and we need to go back to the airport for landing over here in a couple of minutes. As you can see, we are overflying, beautiful view. Hope you like 23,700 feet. We need to leveling off over here. Galactic view over here, and the lakes, the Switzerland, Swiss Alps, the mountains here, the lakes, the Germany behind us, and the France as we are accelerating back to the airport. Galactic view, so the crescent, as you can see. So we start the descent now back to the airport very quickly. So we use idle thrust to pitch down the aircraft, as you can see, and also speed brakes, and increase the rate of descent of the aircraft. We need to come back to the airport. So we keep descending over here. Beautiful view as we are descending. So we have a few more minutes left for approach and landing. Flaps up, increase the airspeed a lot. Also, we have the LNAV also, forgot to mention the LNAV arm in the autopilot. So the LNAV indications we're going to be having armed lateral navigation, altitude, conceals from the head-up display over here. So we have a nicer view of the cockpit again as we are descending, and we have 4 more minutes for the aircraft to reach back to the airport. We descend a little bit faster, idle fast now, and start making the turn, as you can see, as we are descending. So we make the turn over here, as you can see. We need to descend like a few more 1,000 feet and align also with the flight plan. Also we need to follow this way over here as we are keep descending, making a rapid turn, as you can see. So this is a fast turn rate. We need to align over here, cross through all these clouds as we are descending. Here we are, exit the clouds, and we need to align with the runway. We're almost in the runway position. We have 2 more minutes for landing over here, as you can see, almost aligned. We need landing gear down also, flaps extended a little bit, also align with the runway. So we are keep descending over here, you can see. So we need to align over here and keep descending, and we have a couple more minutes for approach and landing. Increase the airspeed also. So 1 more minute, we will be landed. We'll increase the airspeed for approach and landing over here. As you can see, we have the ILS localizer also as we are approaching. Follow the localizer, and also we have idle thrust, a little bit more idle thrust. Align with the runway again. We have the side wing and the wing cast to push the aircraft to the sides, and use more flaps also for approach and landing. So we have manual flight controls, a little bit right rudder, left rudder, aligned with the center line. Also landing gear down. So we approach full landing. As you can see, we have the runway over here inside. So increase the rate of descent over here, align with the runway, side wind and wind cast, as you can see. So we align for the flare over here of the aircraft. So we're gonna be flaring. Flare, touchdown, beautiful touchdown over here. So parking brakes and idle. Thrust reverse over here. Full thrust reverse. And align with the center line, as you can see. So we have a few more seconds actually. So you see the aircraft is slowing down over here. We have the thrust reverse. Only align with the center line. All landing gear is perfectly